Yeah, it's no ideal number. Hello everyone. Hi. How are you doing today? Bad? Yeah. Did you get an exam? Yeah. It's all had it. Oh wow. How are you? Not too good? Well, I don't know. Which cam was it? Yeah. One or two? Yeah, the first one. The first one? And how was your math exam? That was easier than that. Yeah. Did you get your exam back? No, we get it back.
Get it tomorrow.
Tomorrow?
What or what?
Exam.
Oh yeah, online.
Did he post that? Okay, so today we are going to do recitation number week 6. Last week we did week 5, today week 6. It's all about what I know. Just did you guys go over the lecture in class? Online? You did? No?
Not for logs. My video.
Am I ahead of the schedule?
Yeah, because we did 5 last week.
Yeah, I know we're supposed to do 6 today.
Oh, yeah, because he said that we're 2 lectures off or something. So he said he's gonna post them online. We can calculate that. Like we're behind. Yeah.
Oh. See here it says 12. We're supposed to do week 6. But you said you have no idea about log. Okay, no problem. So write down all these properties of logarithm. Log is based on these properties. That's it. If you know these properties very well, you know what to do in the log or about anything about the log. The first property is as long as you have the base. Okay, first let me actually tell you what is base. So log has 3 things. So we have whatever we have on the leg of the log, we call them base. Whatever we have next to the log, it's moving to this. So yeah, we call it argument. And if your log is equals to something, whatever we have on the other side, we call it power or exponent. Oh, I didn't divide that to division. Power or exponent. The log has 3 things. Base on the leg, argument on the side. My argument could spell wrong, okay? I'm not too sure. But the idea is whatever we have there is called argument. And then if it is equals to something, the other side of the log is called either the power or the exponent. Now, log is like a machine, okay? It's a function. What log does it? If you put a big number inside the log machine, and then it does some brr, 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 and then it spits out some small numbers. That's the job of the log. It gets bigger number, turn them into smaller numbers so that you can work with them easily. Now, is there exponential here? Yeah. The opposite of log or the inverse of log is called exponential. Now, log has a graph, something like this, log of x. It crosses through the x value 1 on the x-axis. The exponential function, which is the inverse of the log, has a shape. Let's slow it down. Something like this, which goes to the y value 1. Let's say this is some type of b to the power x. Log and exponential, they're inverse. Why do we care? Because anytime we bump into some problem with the log and you don't know how to go any further, You can turn your log function into the exponential function. And we know how to solve exponential function. Okay? So how do you do that? To turn log into exponential, we switch them around. For example, what we do is we take the base and we raise it to the power and we set that equals to the argument. So exponential function, exponential is some type of base has some type of exponent and we set it equals to argument. Example. If you have log base b of, let's say, c equals d, we can turn this log into exponential by rewriting into a cyclic form. So this is same expression as b to the power d equals c. They both are exactly same thing. They just look different, but they're exact same thing. Okay. So you may wonder, why do we care? Well, we care because we don't know how to work with log all the time. Sometimes we get stuck in the middle of the log problem. So the only way we can get out of the problem is convert log into exponential. Now, this is telling us that if you have the base and your argument the same number, this is same as you have 1. So the log base b and argument b, they cancel out and they turn into 1, which is same as you are saying that b raised to the power 1 is b. So this is what we have here. The base raised to the power, whatever we have on the right side of the equal sign, equals our argument, which is the next to the log. And then if you have log of 1, it means your x value is 1. So it doesn't matter what is your base, as long as your x is 1, your y value is always 1. Sorry, 0. That's because of the graph. When our x is 1, our y value is always 0. So this one is the next one. It says base doesn't matter for the log. If your argument is 1, if the x value is 1, your y value or the exponent is always 0. Which is same as you're saying b to the power 0 is 1. And this is true, right? As long as our base is not 0, anything not 0, if you raise it to the power 0, it equals 1. The next one says log 0 doesn't exist regardless of your base. Why not? Because look at here. When our x value is 0, our log never crosses the not x value, yeah. Our log never crosses the y-axis. So when our x is 0, there is no y-axis. There is no y value. We have in vertical asymptote at x equals 0. So that's the third one. Log 0 doesn't exist. The base doesn't matter. As long as your argument is 0, it always doesn't exist. And then we have some properties. Product, quotient, power. So product says, if you have a multiplication in the argument, you can distribute the log to each one of them. And when you distribute, you're supposed to add them. So if you have log base b of the argument m times n, this is same as log base b of the argument m plus log base b of the argument n. Same thing in the division. You can distribute your log in the argument, but since it's division, so you have to subtract. Anytime you multiply and you distribute your log, you add. Anytime you divide your argument and you're distributing the log, you always subtract. The last one says power rule. If log has any type of power, the argument has any type of power, log hates power, so it brings it down as a coefficient. So you can never leave a power in the log. Anytime you have a power on the argument in the log, you must bring it down as a coefficient. The next property says change of base. So we use change of base because not always we carry a scientific calculator. We use basic one, like our phone has mostly basic one. And most of the time, we're allowed to use basic calculator in the exam, but not the graphing one or anything. But if you notice, the scientific calculator we have, it has a function log, and there is no number here. When you don't have a number here, we assume our base is 10. So by default, we have a 10 base log in our calculator. But let's say you want to find out what is log base 3 of 5. Now, a calculator that cannot calculate this because they don't have the base option. Not every calculator. Some calculator does, but not this calculator. Like most calculators, they don't have this option. So what you do, we want to find how much is it, so we convert this into a base 10. In order to convert this into base 10, all you have to do is you take the log of the argument and you divide by log of the base. Okay? So if you do that, now the base for the log is 10 for both of them, and now we can put it in the calculator and get an answer. What is log 5 divided by log 3? This is 3, doesn't look like 3. Let me rewrite. So that's why change of base is very important. If you don't have a graphing calculator that has a base option. Now inverse property says same thing. The first one, the power comes down, and if you have the argument and the base same, they cancel out. So argument base same means the result is the power only. Next one says, let's say your base has a power, and argument also has a power. And coincidentally, your base and your argument have the same base. As long as you have the same base, all of these cancel out, b log b cancel out, and your answer is x divided by y. The last one says, let's say you have a number, and that number has a power, which is log base something. So if you have a number raised to the power log of the same number as the base, then all of these cancel out. Your answer is the argument. But we have a condition here. Our argument cannot be negative number or 0. So the power cannot be negative or 0, it has to be positive. Then on last property, we use it, why oval shapes? We use it to solve logarithmic equation. It says if you have same base with different arguments and they're equal to one another, it means we can cancel the base with the log and we can set the argument equal to one another and then solve the variable from there. So based on what is given to us, we use some of these. Let me know when you are done writing this so you can see all the questions you have to do for this recitation. Or you can actually take a picture so you don't have to waste time. Ready? Okay, the first page. It says, below the following logarithm. It means simplify. Use the logarithmic properties and simplify. Question? Oh, you're stretching. Okay, so let me show you one of them. The common mistake one, F. Now, before even doing that, let's do E. So E has log base 3, and our argument is 1 over square root of 3. Now we can rewrite this. Change the color. And we can rewrite as log base 3 1 over square root of 3 is 1 over 3 to the power 1/2, which is same as 3 to the power negative 1/2, right? These are the exponent rules from algebra class. Do you guys remember these rules? Anytime you have a fraction, it means a negative power. So we have a 1/3 with a 1/2 power on the bottom. It means we have a negative 1/2 power. So we can rewrite this as 3 to the negative 1/2 power. You may wonder why I did that. Well, I did that because, to simplify your log, we want the base and the argument to have the same number. If you have the same number, you can move further, or you can move forward. Otherwise, you get stuck. So you have two choices. Either you can cancel the log base 3 here, or you can do one more step and you take your power, the exponent, you can bring it down as a coefficient, negative 1/2, and then you have log base 3 of the argument 3. And we know a rule, one of the property. If the base and the argument are the same number, they cancel out and becomes 1. So in other words, you have only negative 1/2 times 1, which is negative 1/2. So a fancy way of saying that we have the number negative 1/2, they use log base 3 of the argument 1 over square root of 3, which sounds so complicated. Any question?
Yes, for the option of canceling log.
Hmm?
You said there's two options. Maybe.
Oh, so either you bring it down and then cancel, or you can simply cancel it in the second step. So we have log base 3 of negative 1/2. You cancel everything and the answer is negative 1/2. So two ways of doing it. Either do it step by step or do a shortcut. Any other question? No. Okay, the next one, the last one. It's a common, like everybody make a common mistake in this one. So let me go over with you. It's the same thing. We have log base 3, and we do see that there is a 3 here. So our goal is to rewrite this so that we can have 3 with some power. So log base 3, how can you rewrite n root of 3 to the power m? Do you remember from your algebra exponent rules? If you have a radical and exponent at the same time, how do you convert them into exponents? We have nth root of the m power. Great. The power goes on the numerator, and any type of radical means it's a fraction. So we have the base 3, our radical is a fraction. Nth root means we have nth denominator, and m power means our numerator is the m. Plus you. So nth root of 3 to the power m is same as 3 to the power m over m. So we rewrite. This is 3 to the power m over m. And just like the previous one, the log base 3 and the argument 3, they cancel out, they become 1. And our answer is whatever we have on the power, m over m. This is m, it looks like 1. Okay. Question. Do you think you can do A, B, C, D by yourself without any problem? can? Try them. I'll give you 3 minutes and then you're going to the next section. So 3 minutes. So right now it's 54. I will start the second part in 57. 3 minutes. Actually, you don't even need 3 minutes. You can do them in 2 minutes. Remember, first step is always rewrite so that the base and your argument has the same number. The easiest one is B because they already have the base and argument same. So what's the answer for B? A. The next easy one is A. Our base is 3. That means we want to rewrite 81 with 3 to the some power. Can you do that? Is 81 equals 3 to the some number? What number? 4. 4. So we rewrite 81 as 3 to the 4th power. And then you see you have the same base and argument. So they cancel out. So what's the answer for A? 4. So answer for B is A, answer for A is 4. And C and D, they follow the same rule. We have 1 over 9. Definitely we don't need a 9. We want 3 instead of 9. So can we rewrite 9 as 3 to the some power? What number? 2. So on the top we have, sorry, on the argument we have 1 over 3 squared. But that doesn't help us because we want 3 as a base, not on the denominator. So we have log base 3, 1 over 3 squared. Can we rewrite 1 over 3 squared as 3 to the some power? That's our goal. Rewrite 1 over 3 squared. This is square, it looks like cube. Can we rewrite 1 over 3 squared? Negative 2. So it's log base 3 and 3 to the negative 2 power. If you don't remember your exponent rules, if you have 1 over x, this is same as x to the negative 1 power. If you have 1 over x squared, this is same as x to the negative 2 power. If you have 1 over x to the any power, it means x to the negative of that power. That's how you convert negative exponents into positive exponent, by making them into fraction. So we have log base 3 with the argument t to the negative 2 power. So what is our answer for C? Negative 2. They cancel out. Now, if you understood C, that means you know the answer for D. So see, all of these are just rules. That's it. Any question? Was anything unclear, confusing? Yes, in your exam, you're going to do few of these. They'll ask you at least 3, I think. Can I scroll up? Are you guys done? Okay, the next one says expand using logarithmic properties. Definitely there will be one in the exam from here. So expand based on whether you have a multiplication, division, or exponent, we use the properties. The properties I showed here. We are going to use these properties to expand our log. B? B, right? Guess what? What's the answer for B? It's not expandable. Why not? With the plus sign. There is no rule for plus or minus in your argument. All the rules you have for logarithm is either for the multiplication, division, or exponent. But here they have a plus. It means it's not expandable. Uh-huh. That's why I picked the easiest one. So remember, all the log rules or exponent rules, everything, they're either for multiplication, division, or exponent. There is no rule for addition and subtraction. So based on A and C, which one you think looks harder? Definitely C. So let's try C together. So we have one term on the numerator and two terms on the denominator. Actually, I shouldn't say term, factor. So one here, and one here. When you expand your log, everything you have on the numerator gets the plus sign, and everything on the denominator gets the minus sign. So the first step, we have three things. So we're going to write three logs. Log base 7 of the numerator, x minus 2 cube. And the numerator doesn't have any other element, so you're going to the denominator. Anytime you distribute your log on the denominator, that term has to be minus. So the second term is minus, and we distribute the log to the first one. We get log base 7 of y plus 6 to the power 2. And then we have another thing on the denominator. So that thing will also get a minus sign. Anything you have, any element you have on the denominator, every element will be minus. Everything you have on the numerator, every element, all of them, they will have plus. So we have log base 7 and z to the 5. So we use rule number 1 and rule number 2. Rule number 1 says if you have multiplication, you have addition when you expand. And if you have a division, it's subtracting when you expand. So we have division on the bottom and plus on the top. And now we are going to the power rule. Log hates power. So anytime it sees any type of power, you must bring it down as a coefficient. So the first power it hates is 3. Then it hates 2. Then it hates 5. All of these, we have to bring them down. So we get 3 as a coefficient, 2 as a coefficient, 5 as a coefficient. All of them, they become coefficients. And we write log base 7 x minus 2 without the part 2, without the part 3. The next one is log base 7 y plus 6 without the part 2. And the last one, 5 times log base 7 with z. So all the things you see on the power, they come down in the front as a coefficient. And then you see, like, can you expand more? For example, here, it's not a multiplication, so it cannot expand anymore. This is also not a multiplication, it cannot expand anymore. And this is a single number, there is nothing to expand, so it cannot expand anymore. That means our final answer is this. That's the that's the maximum we can expand our argument for this log, which isn't bad, right? Any question? No. So what do you think about A? Can you do A by yourself? Since we did the hardest one together. Try A by yourself. And then we have more on the other page. Wow, D definitely looks bad. So let me actually write A and D together. So A is x squared y squared. Log x squared y squared, and what's the base I forgot? 2. So try A and D. B is not expandable. And then we are going to do the other way around. We are going to rewrite an expanded version into a single log. D is expandable, obviously. I'm speaking about B. And yes, in the exam, you're going to have few questions. The first one is simplify, you'll have them. The second one is expand, you have at least one of them. And the third one is rewrite as a single log, you'll have one of them. So you'll have at least 4 questions from here. And I'm telling you what to win the exam. True, right? All you have to do is remember that for your exam so you can practice.
You have to.
Hmm?
You have to.
Combinatory? No, I think combinatory is the last one where you do sequence, series in that time. I think sequence series is the last part, if I'm not wrong. Are you guys done or stuck? Which one? Done? Stuck? On D? What's the first step you think? The numerator has a big square root. What can you do with that square root? Any idea? No idea? Okay, if you have square root of, let's say, xy, can you do something about this? Can you rewrite this? Can you split your square root and rewrite this as square root of x, square root of y? Are we allowed to do that? Do you remember from your exponent rules? Yes, you're allowed to do that because this is a power and we can always distribute the power to everything inside our base. So step 1, distribute your radical to the first term and second term. So we have square root of x minus 2, square root of 3x plus 4 square. This square root and square cancel out. So second term is simple 3x plus 4. And we don't want a radical, we want to see an exponent so that we can bring it down. So we rewrite our first term as x minus 2 with the 1/2 power. So that's the numerator. And we have the same denominator. We have nothing to do on the denominator because they have nothing complicated. And we have a big log. Now, does it look simpler? Can you do the next part by yourself now? Ask me what. I'm here to help you guys. If you don't understand anything, don't hesitate. Ask me anything. So we need to distribute a log 4 times. Twice on the top, twice on the bottom. Everything on the top gets the plus sign. Everything on the bottom gets the minus sign for the top. Ready? So who can tell me the answer? We have log, the first one, x minus 2 to the 1/2, and then plus log of the second one, 3x plus 4. Great. The next one? Minus log of what? X plus 7. And what is our last one? Minus log x minus 5. Are we done? No. What's wrong with this? For the first one, it is a problem. 1/2. We cannot have the power because log hates that. So we must bring it down. So I'm too lazy to rewrite. Let me actually just erase and write this 1/2 on the top, on the front. And now this is our final answer. Looked bad, but actually it wasn't bad. Any question on this one? No. Anytime you don't see a base, it's always time. The next one is the other way around. They gave you the expanded version. Now you have to combine everything with a single log base 5. And since you have a plus sign, minus sign, that means you have a numerator and denominator. Every plus thing you have goes on the top on the numerator as a multiplication. Every minus term you have that goes on the denominator as a multiplication. So how many plus term you see? The first one and the second one, right? So the argument is supposed to go on the numerator. But before you put the argument together, you cannot have any coefficient. If you see any coefficient, you must bring it up as an exponent. So the first term, does it have a coefficient? No. The second term, does it have a coefficient? 1/2. So we must bring 1/2 up on the power of x. So it becomes log base 5 x to the 1/2. For the third one, does it have a coefficient? 3. So we have to bring it up. But what do you see? Our argument already has a power. So what can you do with that coefficient and this power? Are you going to add them multiply them, subtract them, or power them? What you're going to do? So if I rewrite this as negative log 5 x minus 2 cube, we must bring the other 3 as a power, right? So this one already has a power 3, and now we brought the other 3 on the power. So we need 2 powers together. What's the exponent rule for 2 powers together? Do you add them, multiply them, or power them? Multiply them. So it's not 3 to the power 3. It's actually 3 times 3, which is 9. So this whole entire expression, if you rewrite without any exponent, is the first one x squared. The second one has a square root. The third one has a 9 power. And now you're happy. We take all of these arguments, and based on the sign they have in the front, either we put them on the numerator or we put them on the denominator. So x squared, where does it go? On the top or on the bottom? On the top, on the numerator. Then we have positive term square root of x. Does it go on the top or does it go on the bottom? On the top. And then our last term is x minus 2 to the power 9. Does it go on the top or does it go on the bottom? On the bottom. X minus 2 to the 9. Ah. If you want, you can stop here. I wouldn't mind. But if you want, you can also combine them because they're the same base. So we have 2 power plus 1 half power. That gives us 3 half power. You don't have to do that because it's right as a single log. So you have to see how many times you have. If you want, you can do more. Any concept. How do you feel about log now? Do you enjoy them or do you hate them? Or you have no feelings? No feelings? Yeah. Log actually fun, very much fun if you remember your rules. Okay, then we have only one. Oh, write this by yourself. Oh, L, this is not IN, this is LN. So you call them natural log. It acts same as usual log. Log base 10 and this ln, they're the same thing. I mean, sorry, I shouldn't say same thing. They're similar. One of them has base 10 and this ln has an invisible base E. Okay, that's the difference between them. The normal log, the normal one, it has base 10. And if you see the word ln, it's a natural log which has the base E. What is E? It's a number. 2 point blah, 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 blah. Now you follow the same rule, what we did in A, and do your B. And then you'll be done. And this will be into everything. So we have so this 4 belongs to both of them, right? This is your parentheses here. So it's 4 times 3 and 4 right? So 4 times 3 is 0. So then why do you have any of speed here? And this one is 4 power. And then I'm 4 coefficient. The next one doesn't have any power. It's almost time to get the balance. What you wrote them wrong? Because this 4 belongs to everything. So we have a big parenthesis here. So you distribute to 4. 4 times 3. 4 to the second one. 4 to the third one. So the denominator also has a 4 power. Mm-hmm.
We never signed the sheet today.
You're not done here, right? Look at power. So anytime you have power, what do you do? Mhm.
We signed the sheet today.
Wait a second. I forgot. That's okay. So you didn't go anywhere and multiplied. Or let me show you here what I did. 3 by square root, you distribute to both of them. And I forgot about that. So you distribute the square root to both of them. So you have square root of the first term, square root of the second term. But the second term already has a square. So square and square root, they cancel out. That's why it doesn't have any power. Only the first one does. If you are not done, make sure you turn it by Friday midnight on Lumen.
How come the 3x has
So we have C here. If you have multiplication, you distribute your radical to both of them.
I emailed you last week about I was trying to submit, right, and it was not letting me know. I'm gonna try again today, so that's why it was delayed. Oh, it's not letting me.
After Friday, it will get finished. That's the thing.
Oh.
So I'll reopen again. But make sure from now on, submit before Friday midnight.
I tried submitting all of them before Friday and it wasn't working. Yeah, it was 4 and 5 for me.
Before Friday midnight, it didn't work.
Yeah, no. But I had them on my files already saved and done, and then when I tried uploading it, it said, well,
Okay, I'll open them again. And if it doesn't work, then you'll.
okay, thank you so much.
The first one is wrong. What is your rule? The first one. 2A. No, 2A. Okay, the same. Oh, here, this one. So we have square root of x and square root of y because you split your radical into 2 pieces. Same concept is here. We have the first one and second one. So first one is x minus 2 and second one is 3x plus 4, which is square. So when you split your radical, you split it this way. The first one has nothing to cancel, so it becomes x minus 2 with the 1/2. But the second one is square root and square. They cancel out because they are the same. And log hates power, right? So what do you do with the power? X to the square and y to the square. What do you do with the power? Anytime you have a power, what do you do with the power?
Wait,
You bring it down as a coefficient.
oh,
No, I thought.
Is it this?
Perfect.
Thank you.
So goodbye, everyone. See you next week.